Hello, everyone. My name is Brock, and I am the chief architect at Nascent. We're an early stage venture firm. Just to go over what we're going to be talking about today, going to do a little getting started, talk about some basic tests in Foundry, talk about Forge Standard, cheat codes, traces, Anvil, fork tests, fuzz tests, advanced cheat codes, new features, and a sneak peek of something that I'm building. It's a lot to cover, so the kind of basics I'm going to blow through pretty quickly, but then kind of dive in on some more of the new features that have come out. But I want to make sure everyone has a baseline for where they're at with Foundry. So to get started, all you have to do is three basic commands: get the Foundry up, run Foundry up, and forge init. For some context, basic tests, there's a setup function in each test. This is ran before each test and is sort of before each block. You also have test functions. They are prefixed with test, and you have certain things like assert equal and assert true. We also have test fail. That is deprecated. Please do not use that, but it is there for legacy code bases if you were AdaptTools OG. Forge Standard is a set of utilities that really amplifies the usefulness of Foundry and the cheat codes that are inside of it. A cheat code is basically your way to modify the state of the EVM. We also have things like standard assertions for helping writing assertions, standard math for math-related testing, so delta, percent values, that sort of thing. Standard storage, this is for modifying the EVM's storage, and standard cheats. There are a lot of cheat codes. I recommend checking out the Forge Standard library. It has a interface that has documentation for all of the cheat codes. But standard cheats is a wrapper around a lot of those cheat codes to make them more user-friendly. Basic cheat code. So you have a VM. This is your entry into the cheat code world. It's an address that is in the basic Forge test contract. Expect revert. Basically prevent a reverting call from ending execution. Prank, send a call to someone else. Deal, send an Ethereum balance. You also have traces. So when you run Forge test, it will not give any other output than whether or not your test failed or succeeded and the gas it used. But if you add a dash, I will put this in the chat, 3Vs will showcase the failed test, 4Vs will show the traces for a passing test. And you can see the usage here. So you have gas, the contract, and the function call, and the parameters. And we'll see a little bit about that later. Green is that it did not revert, red is reverted, et cetera, et cetera. We also have Anvil. Anvil is a blazing fast Ganache replacement. Just run Anvil and you get a node that functions similar to Ganache or Geth. And it provides you with accounts that you can load into your tests or deployment. So through Anvil and also just normally, you have fork tests. So this has been in Foundry for a while, but there are some new additions here. One of which is the ability to modify the forking in Solidity. So it's accessible in Solidity. So here you can see we have a mainnet fork and an optimism fork. So this is if you are writing an application that maybe talks to both or is deployed on each, and you want to make sure that it's going to the contract is going to act the same on both sides. And so we have the create fork. This is very similar to this, the fork URL, as well as the optimism one. You can test inline for the ID, and likewise you can switch forks as you go along. The upshot of this is, as you'll see later on with scripting, you can actually do multi-chain deployments. There's some caveats there, but through this, you're able to do some pretty cool things. All right, fuzz tests. again, we had these the last time I gave this talk. Very basically, it's property-based testing, which I feel is superior to unit tests. Both are necessary, but you're more likely to find bugs with fuzz tests. If you encounter a repository that does not have fuzz tests and you're auditing it, I would highly recommend either adding the fuzz tests yourself or writing them as you go along in the audit, and validating that if they wrote the fuzz test that they work appropriately. Additionally, Foundry and Hardhat are now much more interoperable than they were. So it can still take a little bit of work, but for the most part, you should be able to add fuzz tests with Foundry into a Hardhat repo. I feel that is the number one complaint I have with Hardhat these days, is that there's no fuzz tests, and JavaScript, of course, but there are no fuzz tests. And so you'll see a lot of repos that are in Hardhat that should have fuzz tests that don't. And so here you can see a basic unit test. This seems like it would be successful, but if we change it to a fuzz withdraw, if we fuzz it, you basically just change the test to take a input like this. I like to denote test fuzz so that you can do this. But when you run this, you'll actually see that it returns an error. It fails, yada, 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 with a large value. And the reason that is because when Foundry initializes the testing contract with 2 to the 96 ETH, but this value is larger than that. So we saw that it failed. And so in general, you'll see something like this, where you'll have a bound, which bounds the fuzzed amount between 0 and the bounds, for example. You also have VM.assume, but in general, bound is going to be more consistent because you don't. Foundry keeps track of how many failed fuzz tests you have, and there's a maximum so that you don't just keep spinning your wheels without making any progress. And so bound is provided by Foundry and helps out a lot on fuzz tests. And as you can see, when you run this, it is successful. So I want to talk a little bit about some advanced cheat codes. So we saw the basic ones like expect revert. Wait, did I actually forget to do that? That's okay. So you have a cheat code called deal. So this is with the standard storage, and basically it lets you act like you have full control over an ERC20. So you can deal the address of an ERC20 to this address, specify the amount, and whether or not you want to update the total supply. And kind of under the hood, you can see in this test write arbitrary, this is sort of the call that is being made in here, where you specify the target contract, you specify a signature, and then you can write to it. So here, it would set this A variable to 100, even though there's no possible way to set it otherwise. And I would recommend taking a look at this because it can be super helpful. You can also do arbitrary reads. So I could, even if this, you can do some pretty cool stuff with standard storage. I recommend checking out the Foundry standard library. It has a whole bunch of tests for this standard storage mechanism. Additionally, so I recently rewrote Optimism's Bedrock deployment. They are using Hardhat for deployment, and we relatively recently added scripting a little while ago, but we also added some really cool ones like read file, write file, parse JSON, etc. And so part of that is they have a special configuration based on whether or not they're deploying to Hardhat node or mainnet or their own layer 2 Optimism. And so one thing you can do as you get more into the VM cheat codes is you can take JSON and parse it. So if you have a configuration JSON, You can, in your setup function, load it in based on the network. So you see here the environment string. So that is just loading from the environment. We do some concatenation. We read the file into the storage variable. And then we're able to read from the deployment config, for example, my var. And I also have this default config thing here, but it just goes to show how powerful this VM read file, write file, that sort of thing. And so if you want to also have a particular deployment configuration, so let's say you're deploying to mainnet and you want to record the inputs there, you can create your own artifact for the deployment if you want. And so I think a lot of this is super powerful. So I want to now jump into some new features. The first of which is Forge script. I want to talk about Forge coverage, some of its limitations. We recently added Forge doc, which is a markdown processor for NatSpec. Chisel, which is a Solidity REPL. Some new cheat codes, multi-chain deployments, and invariant tests. So Forge script, basically the concept is that you should be able to write your deployment scripts how you write any other Solidity. So for example, here, we just load in a private key, we set our deployer, and all you have to do is call vm.broadcast. And this is very much like vm.prank, except instead of changing the caller, it changes the EOA, and anything that occurs after this broadcast, well, the next call that occurs after this broadcast will create a transaction under the hood based on this input. So if it's creating a new contract, if it's calling a non-static function to a live contract, if it's whatever, this broadcast will record that transaction and then create it. And so let me just, sorry, 1 second. Can you guys still see my screen? Let's see. Okay, great. So if I run Forge script and all right, sorry, never mind. This would create a transaction here that lets you deploy this. And so since we supplied the deployer there, it would send it from whatever we pass in as our private key in the environment. There are other ways to do this. I find this is the most elegant, but I just wanted to showcase that a little bit. So Forge coverage, we now have Forge coverage. So here you just see the basic output, but you also have the ability, it generates LCOV, which is a standard for coverage reports, and you can get an HTML report. There are some cool GitHub actions that will report it directly in a comment to a PR, so it can tell you whether or not you increased or decreased your coverage. Some caveats about this is currently it does not support VIR and it does not support optimization. It automatically turns that stuff off for you. So part of the issue is that when you have the optimizer on, either via IR or just the normal optimizer, it modifies the bytecode such that the source map, which tells Foundry how a particular AST node maps to the executing opcode, that gets jumbled, and so you lose a lot of information. So we have to turn it off. Unfortunately, what that means is for contracts that require the optimizer or VIR to avoid stack too deep, it currently does not work. As we approach a world with the EVM object, and there's an EIP that allows for swap n and dupe n. In theory, this limitation will go away as stack too deep goes away as well. I don't know exactly the timeline for that, but you're a little handicapped by that, but a lot of teams still are able to utilize this pretty well. And if you do have issues, you can always switch to using structs instead of a million variables. So Forge doc, this is sort of the output of what it looks like. You are able to take any NatSpec documented contract, and it will generate markdown similar to this, right? So counter is the name of the contract and has these state variables and these functions, and it allows you to do MDBook. So MDBook is a Rust-centric, it's built in Rust and popular in the Rust community. And so if you like that style, it's the same style as the Foundry book. So if you like that style, it's great for that. There's a chance that we may in the long term switch to a more docs.rs style, but for now, MDBook works well. And so I want to showcase Chisel. Chisel is really cool. It is a Solidity REPL that lets you do some pretty cool stuff. So if I run Chisel, I can just treat this like if it were a Python prompt or anything. So A equals 100, A plus A, and it gives me a little output here of the type and the decimal. And I can do source. I can see, okay, this is kind of what it's doing under the hood. It's bringing in the cheats. It's creating this contract. And as I do more, you can see it updates. And so I can always just check what the current state of a variable is right here. It's very cool. It was created by, I believe, Vex and RefCells on Twitter. I highly recommend following those guys. I find myself hopping into Chisel for testing weird Solidity things, and you can also export this into a file and that sort of thing. So it is really, really useful. Highly recommend checking it out. So some new cheat codes. I already touched on parse JSON and the other JSON functions, but I really, really like those. And then the file manipulations as well. You also have recently added pause gas metering, resume gas metering. So basically what this lets you do is if you have non-pivotal, if you don't care about the gas usage for contract setup or anything like that, you can pause the metering and then resume it. There's even a modifier in Forge Standard that will wrap the function call with this pause gas metering so that you can have more control over your gas reports and those kinds of things. Now, just want to note that Solidity doesn't manage memory. And so if you have any for loops or anything, they will blow up your memory. And there is a configurable memory limit set in Foundry. It's simply in the foundry.toml, you modify the variable memory _ limit. Additionally, transact. So this is when you are using a mainnet fork, you can fetch a transaction and execute it in the current state. So if you want to just take a live transaction, maybe it's a hack, maybe it's a governance proposal, something like that, you can pull the actual state, execute the transaction in your local environment, and continue on from there. So I wanted to now dive into some invariant tests. This is kind of the feature that I'm most excited that we have, and I think that it is likely going to be the most powerful tool in Foundry. And so let me switch my screens here. Actually, okay, you guys should see over here on the right, this is the Optimism Bedrock repo. And you see here they have this invariance folder. So they're using a combination of Echidna and Foundry for their fuzz tests and their invariant tests. I was talking with them about how they felt about Echidna versus the Foundry fuzzer, and effectively they like both, but they are going to be moving to purely Foundry going forward because they find it is easier to write, they enjoy writing Foundry tests more than they enjoy writing the Echidna test. But Echidna is still a very powerful tool, and I recommend either, as long as you are fuzzing and invariant testing. That is the most important thing, whether or not you use Echidna. I know Spearbit did a session with the Trailbit guys who wrote Echidna, and if you want to deep dive into Echidna, recommend checking that out. But I want to highlight in invariant tests. So, sorry, what is an invariant test? An invariant test is basically if you were to take your entire contract set and can't see Brock's screen. Are you guys able to see? You should be able to see on the right an editor and on the left a terminal.
All good here.
Okay, great. So an invariant test it's a little weird, but it's basically a stateful test where it will chain calls together to try and reach a state that you don't expect, right? So an invariant is it's you saying, I promise my contract will never reach X state. So in this example, right, they're basically saying in this invariant, for all of the calls that were made, each of them should be successful and none of them should be failed. But there's a little bit of a weird setup here, right? So there's this invariant test contract and there's this actor contract. And so you'll see this pattern a lot in invariant tests where you have an actor that is acting on the state of the world that you want to explore. It's not entirely necessary, but it is the best way to write invariant tests at this point in time in Foundry. So we set up this actor, and then we specify the target contract. So this is telling Foundry which contract do you want to look at for what functions to call. And so we're specifying, okay, the only one we want to target is actor. And so that means that when Foundry is picking what contracts and what functions to call, it'll only look at this relay actor. And so this helps focus Foundry and make the use more useful. And you also have the ability to target selectors. And so in this case, they create the selectors. It's only one because there's only one function in here, and that's relay. And so just like how and then it treats Foundry invariant tests treat this like a fuzz test. So there is a pseudo test fuzz here, right? And I can zoom in even more. So it treats this relay function as a fuzz test, and it will chain multiple of these for a certain amount of depth. And so that is configurable in foundry.toml, and you can kind of get a sense of what they're doing here, right? So they're specifying an precompile. They're doing some vm.store. This is kind of what I was touching on earlier, where vm.store is a very powerful thing. So even if you don't have a public function to read or write a particular variable, you can still go in and actually modify the slot. And so kind of what this is doing is making sure that the min gas will always relay message should never revert if the proper min gas limits are set. And so it's fuzzing this. They're doing some bound correction, so kind of like making sure the version is correct, that sort of thing. And then they actually call their relay function down here, and they prank it as the op, which is just it's the portal for optimism. And so what this will do is it'll continually call relay with new inputs and new inputs. And I was actually running this and found that this invariant doesn't hold because it's actually just it's not correctly written. So if I uncomment this, right? So this test would actually fail because the relay expects that you never have the same message twice. And so if you just pass in a blank bytes right here and the same value for the gas limit, it'll fail. And so you do need to do a little bit of finagling with this. And so you could have another thing in here in the actor. This is why you kind of use the actor. So you could just do a check here where you could do a require hashes does not contain hashes does not contain the hash, right? And so that would prevent that from failing. But this is kind of a good setup in general for how to do invariant tests. Similarly, you have other ones that aren't. This is a good example of not really using an actor. You just kind of target the contract that you want to call, set the sender. You can set the sender and the selectors that you want. And all this test is that the block number is always monotonically increasing. Similar here, you make sure that it's always the gas limit is always increasing. And I guess I can run the test here. And so you can see you have the runs, the number of calls that were made, how many reverts occurred. And you can do, I don't remember if this works currently. It does not, but that's, oh yeah, there it goes. So you can see, I know this is a lot of junk, but it basically is, it calls the number of hashes. This is the invariant, and then it'll continually just build these sets of transactions so that you're trying to guess what the next or what will put your contract into a bad state. Does anyone have any questions? Monotonically increasing just means it always increases. So you'll never have a up, down type of situation. Anyone have any, will it try testing all invariants or will it stop once some invariant failed? That is configurable. And I don't remember the configuration name off the top of my head, but I believe for a particular test, if it fails, it may always end that test, but it won't end the entire test suite. But again, it might be configurable. I just don't remember off the top of my head. Does anyone have any questions on the invariant test? Cool. Let me switch back over. So I want to give a little sneak peek about something I'm building. This is not necessarily Foundry related, but it will have impacts on Foundry in the future. And so after I kind of explore this, I want to answer questions on Foundry and what I'm building right now. If anyone has any Foundry questions right now, let me know. Otherwise, I will dive into what is called Pyrometer. So it's a new tool from us at Nascent. It's separate from Foundry, but it is effectively abstract interpretation, which is similar to symbolic execution. And what it does is it can perform bound analysis. So something to the effect of uint 256x is in the range 0 to 2 to the 256 minus 1. You can write storage write queries. So how can I set this variable to a particular range? So if it's a Boolean, how can I write it to false? How can I write it to true? You can do chain analysis. So are all of my writes to storage checked? So is there some validation on each of my storage writes? Additionally, I kind of think of it as Slither on steroids. Slither is great, but it lacks some depth in certain cases where I think this will really fill in some of the gaps. It can do things like Slither in the future, but that's not the priority. The priority are these. So it will have some constraint solving. By default, it sort of does a little bit of constraint solving, but really what it does is it highlights the constraints right now. So we'll see that in a second as I give a demo. Also, it is insanely fast. It's about 1 millisecond per contract. Depends on how big the contract is, that sort of thing. But it is really fast, and there's a case to be made that it belongs in an IDE. So while you're developing, you'll be able to get the bound analysis and see how things are evolving as you go along. And so now I'm just going to run this. And so, this is frustrating. I want to show both the contract and the output here. Give me 1 second. Where are you? So here's the contract on the right. It is a contract that Harvey's the consensus tool fuzzer consensus diligence team put together called Harvey, and it is basically a exploration in this sort of complex, okay, how do we reach state 1? How do we reach state 2, etc. And so let me rerun this. And so what we see here is it works off of sort of a world forking mechanism, right? So when we enter Baz, there's only one context, right? So the basic context. But then when we hit this if statement, you can think of this as splitting the world in two. One where D is less than 1 and one where it's not. And so now you have two contexts, two worlds. Additionally, when you every time you hit an if statement, it will create another fork. And so you can think of it as this big branching tree of, okay, this forked, this forked, this forked. And if you hit a revert, then it kills that fork and you no longer evaluate things in that fork. And so when we run this, we can see here, okay, D is in the range -1. This is for where D is in this and B is in this range. So what that is negative into 56 max to 0, and where B is negative into 56 to 2. And so we see here that if those are the case, where D is in that range and B is in that range, you will reach this state and write storage variable state 1 to true, and then return 1. Additionally, we have these other bounds where, okay, to reach state 2, A needs to be 42, D needs to be in this range. To write for state 3, the only bound we have is D is in this range. Now, this is not complete, right? We're not taking into account the inverse, right? We're not saying, so if you look on the right here, to reach this, A cannot be 42 and B can't be less than 3. And so on and so forth. And so this is a basic example of just analyzing the bounds on your function. It's not perfectly clean yet, right? This is still very much a work in progress. But you can also do things like, so if I want to, this is kind of the storage query, right? So baz, and we're calling the baz function, and we want to write state 1 to true. So if we run this, we'll get sort of a similar response to what we got before, but found storage, right, that could lead to state 1 being true. B is in this range and D is in this range. And so it tells you how to reach a particular state for a variable. And you can do this with integers and uints and that sort of thing. Kind of longer term, where I also want this to go is, you see this like eval bounds. We can actually turn that to false. And let me just back up here. Let me take this. This is a cool example. This. So what we're doing is just evaluating this super complex function, but I want to kind of showcase some more of the functionality. Oh, sorry, I've been making changes. Let's see. All right, sorry. Anyways, this is what happens when you kind of demo a work in progress. But one of the other things I want to do is, if you think about, I don't know how many of you have looked at Soulmate ERC20 implementation, but it has this cool invariant in it where it is able to do the transfers with the balance changes unchecked. So when you add the balance to someone else, that can be unchecked purely because the total supply is, there's a link between total supply and balance, where the invariant holds where total supply is guaranteed to be equal to the sum of balances. And so since the total supply is checked, balance can be unchecked. And so what that allows you to do is this balance unchecked business. But what I want this tool to be able to do, my tool, is to surface these kinds of invariants, right? Where total supply, the only way to adjust the balance of or introduce balance of is via the mint function. And mint function is corresponding to the total supply. Therefore, it would basically spit out this invariant that, yes, you can make balance of unchecked in transfer. So that is kind of an overview. Happy to answer questions. Do you base your symbolic execution on the AST of the Solidity source? If so, what do you use to build it? So I currently don't want to have solc as a dependency. So I'm using a parser called Solang. And basically all I do is there is a parse function that basically takes in the source and starts the parsing process. And there's actually a graph that underlies a lot of this information. So it constructs a graph of the contract and its functions and function return parameters. And then the function body is this special context. And that's kind of where the forking occurs. And so we don't use the AST. We just parse the actual raw Solidity via Solang and kind of construct this IR based on it's a graph IR effectively. Release ETA. So hard to say. I would love. I'm looking for beta testers soon-ish. I was hoping to get some beta testers this week, but most likely it's going to be another couple weeks before I'm ready for some beta testers. I would love to have a decent system ready for ETH Denver. In which case I will maybe release open source at that point. I want to put this tool in the best light I can, and so I'm not going to fully release it until it's a little bit more solid. As you saw, we had a crash in the demo, so yeah. Does anyone have any questions on this or Foundry, whether it's how to best practices for fuzz tests, for invariant tests, for unit tests, anything? Oh, I am in the wrong chat. Will invariant testing automatically make new blocks increase timestamp? No, you would need so one way you could do that is you could just have in the actor, you could have a increase block number or increase timestamp. And so periodically, Foundry will pick that function to call and do that for you. It'll be random when that occurs, but it is a even distribution amongst the function signatures. So, a uniform distribution amongst the function signatures that you approve for the invariant tester. Here is my audio question. So this is asking such that it can be a drop-in replacement for Echidna. So they aren't entirely replaceable with each other. They are very similar. But effectively what you would do is, let me reopen this and contracts Echidna. Okay, so this basically, that one's not a great example. This is a better example, right? So you have test round trip A to B, test round trip B to A. And I believe this is likely a stateful test here, where you would call one and then the other. Basically, all you would have to do is actually switch this to invariant and have a setup function to kind of specify that you want it. I would pull this out actually into a different contract, and I would have a setup function that points it at this. You would make this an actor effectively, and then you would have this invariant here, and here. How practical do you think symbolic analysis will be? Will it be performant enough to be used on more complex code bases? So I'm assuming this is about my tool. In general, we are in depth as Z3 SMT solver type things. I want to add that as a potential feature for it, where you can basically, we would construct the questions that you would pose to the constraints that you would pose to a solver like Z3. But I want to try and do as much as possible in my own very heavy-handed systems. Why is there a difference between gas usages when we run tests with and without broadcast? So the reason that there is that difference is because when you are executing something in Foundry, you're doing it in the context of a contract, right? So we deploy a contract and you just call this function. And so when you call that function, you have it changes some of the semantics with how gas is calculated, right? Instead of a base 21,000, it's base 2,300 or something like that. If it's a cold address, something like that. So it's basically just comes down to whether or not you're sending it as an EOA versus inside the context of a contract. Any doc about the actor and variant actor selector pattern? Currently, no. But there was I think 3-hour stream or so featuring Georgios, Matt Solomon, and Lucas Manuel from Maple, where they did an absolutely tremendous deep dive into Maple's invariant tests. And they, I would say, have the gold standard for invariant tests. So if you're looking for, okay, how to set this up, I would check out their repo. I don't necessarily like how they've done their module systems, but their actual invariant and actor pattern is very, very good. But it has some weird inheritance things that you'll have to kind of wade through to get to the actual meat of how these are set up. But we do, if you think you're an expert in the actor pattern or are feeling adventurous and want to explore it and then write up the documentation for the Foundry book, that would be incredible, because we do need to update the Foundry book with that. There may be ongoing work already for that, but I'm just not sure. Any other questions? Is there a way we can get gas usage for the test without broadcast, which is near to the actual usage when executed using broadcast? Yeah, so if you run, so if I were to come over to here, let me see if this works. Sorry. So I believe you're asking, so here, right, we said gas used. Let me get some more verbosity here. Here you're saying, okay, the entire run did 104 gas. Let me kick up Anvil real quick, just a quick Anvil. And now RPC URL is B. So here we can see, okay, 102,609. So that should be the actual gas that was used, because it's not doing anything fancy. It's literally just looking at the transaction and simulating it. And so that when we actually run it, it would cost that much. So if I actually broadcast this, so I can add the private key and I can do that. I think I actually need, and I add the broadcast flag. So here you can see it was slightly different. I imagine it's because we used a different gas price. Yeah, we used 4 gwei instead of 5 gwei. But you can see, okay, yes, it really did take 102,609, which is what we simulated here. When invariant testing, getting error no contract to fuzz. Is that because the target contract is not set? Probably. I imagine so. Yeah, you do need to name it invariant. Also, it helps to inherit the invariant test. So in Forge Standard, we have the invariant test. This you should have your invariant test include that. So it would be like invariant test, like that. Yeah, we're missing the use directive in Chisel. Eventually, you'll be able to just specify the path or version that you want for Chisel, but currently not yet. There's an open issue for it, I believe. Savior, was that you're asking when it was more complex, it consumed different gas, hence why the question. Was it a mainnet deployment or was it a local AML deployment? Oh, I also forgot to mention very quickly on pyrometer. So this is actually going to supercharge this is the integration of pyrometer in Foundry. So this is actually going to supercharge the fuzzer, right? So think about the fact that we would have to randomly try and guess C is less than 42 while these other requirements hold, right? We can actually, now we have these really interesting variables for the fuzzer to try. And so we can actually do this analysis and then pass this information over to the fuzzer and be like, hey, these are some interesting values. And so I imagine our fuzz coverage is going to go up dramatically once we seed the fuzzer with these interesting values that we generate from pyrometer. How much analysis does Foundry actually use under the hood regarding stack mem storage bars? So I assume you mean for fuzzing, and the answer is not a ton for those 3. It does grab return values a lot, and it creates a dictionary of sort of interesting things it picks up, right? So it analyzes your code, it picks out things from your code and adds it to the dictionary, and it will randomly pick either from the dictionary or it'll generate a random one. And so we have looked into doing like the stack and memory and storage lifting into the dictionary. We just don't currently do it. It would kind of blow up the size of the dictionary, I think. But there may be use cases for that. I think likely the path we go down is sort of the intelligent pyrometer seeding the fuzzer. Any way to kick off the debugger in the middle of a function? No, unfortunately. What you can do is you can do just kind of a basic function call and then jump to it quickly. So if you hop into the debugger, VM start debug. Yeah, I think there's a lot of room for improvement on the debugger. If you guys have thoughts on the debugger, feel free to reach out and share on the Foundry Telegram or whatever. I am more than happy to take a look at some of that stuff. But one of the basic ways to do like VM start debug, if you do some basic VM call or identity precompile or something, you can quickly jump to that call just by hitting Control C, or sorry, Shift C. Okay, last couple questions here. How can we clear the traces in Chisel every time it will show all the traces from the start? It's a good question. I don't actually know. Is Foundry working on corpus integration? There's been talk of that. I think there's an open issue for it. I don't know what the current status of it is. A lot of the Foundry contributors are also contributing to Reth, and so some of the more active contributors have slowed down a little bit. But if there are things like corpus integration that people really, really want, I know it's being worked on, but or at least, yeah. Cool. Well, thank you everyone for coming to the seminar and listening to me. Feel free to reach out to me on Telegram at Brock Elmore, on Twitter at Brock J Elmore. I am always happy to answer questions and bounce ideas around. And feel free to ping me if you want to be a beta tester for my tool. I think it'll be really helpful for auditors and understanding code just from a basic developer standpoint as well.